Hello, today I'm going to go over the Chapter 8 review for Math 111. This would be your final test material. And this is all over Chapter 8, which has to do with radicals. I'm going to go ahead and get started doing this. The best way to do this test and study for this is to go ahead and practice these problems and watch these videos to make sure that you're understanding what you're doing. Also work on the review that your teacher might have gave you as well. Without further ado, let's go ahead and get started here. Number one is asking us to simplify this radical and assuming that the variable is positive. The reason why is that this is a square root. How do I know it's a square root? Is because right there is nothing in the index that tells me that it's anything but. If you don't see anything there, we always assume it's a square root, which has an index of 2. That's why it's called a square root. Like if you could say something like, 3 squared is 9, so 3 times 3, 3 to the second power, that's where that comes from. So to break these down, I'm doing the opposite. The one thing you have to know for this test is you really want to know your squares, your perfect squares. So things like 2 squared is 4, 3 squared is 9, and so on. You want to know all of those. Because 81 is 9 squared. So what I like to do is break them up with the numbers separate. And you could do this. The nice thing about radicals is that if you're dividing or multiplying, you could break all 3 of these up into separate radicals, work on them, break them down, and then put them back together. So the first one, 81, we just said that's the square root of 9. So this would come out completely as 9, no radical. The next one, I want you to think about these two as division. How many times does 2 go into 9? Well, it goes in 4 times with 1 left over, right? So what would happen is this would be y to the 4th, because that's the 4. 1 left over would be y to the first power inside a radical. So that's like saying 2 goes into 9 4 times with 1 left over. For the next one, 2 goes into 6 3 times perfectly. So this would be x to the 3rd, nothing left over. Now what I want to do is put all these together. Everything without a radical will go next to each other, so I'm going to have 9, let's say x to the 3rd, y to the 4th, and then whatever is in the radical goes last, and anything else that would be in the radical would go together. So this should be my answer for this problem. Okay. The next question is asking us to simplify, but here we're not actually having to, break something down with variables. We are going to have to, add and subtract this stuff. Well, first thing I notice is none of these are the same. The nice thing about radicals is if I had, 3 square root of 2 plus 5 square root of 2, I can add this. I treat this as if it was the same as 3x plus 5x. So my answer here would be 8x. And in this case, my answer would be 8 square root of 2. But I don't have that here in this problem. I have to make that so. So what I need to do is, again, look for these perfect squares that are hiding in this problem. Okay? So I got to think about what do each of these numbers break down? What is inside of these? Well, knowing my perfect squares, I know one of them is 9. 9 goes into 18. So I'm going to go ahead and do that. Minus 6 is going to stay the same, okay? And this first one is a cubed root of 27. Cubes are a little bit different. 2 to the 3rd power is 8. 3 to the 3rd power is 27. You want to know the cubes up to about 5. So the 4 cubed is 64, and 5 cubed is 125, like that. Okay, so make sure you have those memorized. If you're able to have a cheat sheet, put those on it. Put the squares on it as well, all of them. So this reduces down to just 3. Now, whenever this 3 comes out as a number, I'm going to actually multiply these two. Not now, but in a minute. 18, I know, breaks down, and I'm going to break it up where the square, the perfect square, 9, is going to go by itself. 18 is 9 times 2. So I have a square root of 9 and a square root of 2. I can do this just like I did up here in this problem. They're just going to sit next to each other. 25, a perfect square that goes into that is 50. 25 is a perfect square. So I get minus 2, square root of 25, and square root of 2. Square root of 25 and square root of 2 multiply together, give me square root of 50. Okay. But now I'm going to break down what I can. Here, multiplying this together, I get minus 18. Here, I'm just going to take this one, because that's the one I can. That's going to give me minus 3, square root of 2, like that. Okay. And now here I'm going to take that one, and I'm going to get minus 5 times, minus 2 times 5, sorry. Just like what I had here, but now I have it here. I need to do that, which I will in the next step, times the square root of 2. So minus 2 times 5 So I get minus 18, minus 3, square root of 2, just copy. Minus 2 times 5 is going to give me minus 10, square root of 2, okay? Now these two very much look like this. I can add and subtract them. They have the same radical. So minus 3 minus 10 gives me minus 13. So my final answer is minus 18 minus 13, square root of 2. That doesn't become square root of 4 or anything. It doesn't change. Stays the same. That one right there. Final answer. Alright. Let's go on to the next slide. The next slide says write as a radical and simplify. Okay, so remember exponential, whenever you have fractional exponents here, and then radicals are similar. So if I have a radical like this, and I have parentheses around it, let's just say, you have a number here and a number here, the index and the power, or the root and the power, okay? So how do I know which one of these goes where? All right, the top one is always the power, and the bottom one is always the root. So this would be the power, this is going to be the root. So then what I'm going to do is just literally plug them in. So I have 1 over 125, it's still going to stay a fraction, okay? Here's my radical. What goes in my radical? Well, the root is here, 3, and the power is 2. Now, I'm going to go ahead and take the cubed root of this first, okay? I know that 5 cubed is 125, so this denominator is going to be 5. What's 1 to the, what's the cube root of 1, or what's 1 cubed? It's always going to be 1. So I know 1 over 5, that takes care of my radical, squared. So now I just do 1 squared and 5 squared, which is going to give me 1 over 25. That's my answer, okay? And the first step was to rewrite it, and I had to get an answer. Alright, the next one says write in exponential form. It doesn't ask me to solve it, so let's just go ahead and just write it. Knowing what I know about my power and my root and how that relates here, I'm going to go ahead and do that. So I have 11, okay? I have parentheses. I'm not going to have a radical anymore. That's going to go away. And I know that the power, the 2, goes in the top, and the root is the 3 in the bottom. And that's it. That's all I have to do for this problem. Now here's this first multiply the radicals, then simplify the multiplied radical. So again, what I want to do is I can go ahead and multiply them together and then break it down. Or you can do it the other way. I know it says for us to do it this way. So what I want to do is find out what is 18 times 6, which is 108. So I now have the square root of 108, okay? Now, looking at 18 and looking at 6, those multiplied together give me 108, but how do they break down? Well, 18 is 9 times 2. We know 9 is a perfect square. And 6 is 3 times 2. I know that 4 is also a perfect square. So what this is telling me is that 108 is the same as saying that you have 9 times 4 times 3. Because these together would give me 4. And I have the 9 and the 3. So now that I know this, I'm going to break this down by the squares. Because if I sat here and tried to do the square root of 108, I'm not going to get anything. It's not a perfect square. Okay? That's not going to give me anything. So I need to do the square root of 9. So the square root of 108 becomes the square root of 9 times the square root of 4 times the square root of 3. Both of these are perfect squares that can be simplified. I get 3 times 2 times the square root of 3, which if I multiply those two together, I get 6 square root of 3. That's my answer. Now down here it says multiply and simplify the radical. Okay, I can't combine anything inside my parentheses there. That's the first thing we always want to check. But I am going to go ahead and just multiply. See what I can do. So, square root of 5 times square root of 6 gives me the square root of 30. Okay. Then I have minus 5 times 12 is the square root of 60. Alright. Okay, looking at this, I cannot simplify the square root of 30 because the square root of 30 is 5 times 6. 6 isn't a perfect square, 5 isn't a perfect square. There is no perfect square hiding. There is one in 60, the number 4. 60 breaks down into being 4 times 15. So 4 can come out. So I end up with the square root of 30 minus the square root of 4 and the square root of 15. I could simplify this, square root of 30 minus 2 square root of 15. I know what you're thinking. Oh, can we possibly break down the 30 so that I could do something with the 15? Unfortunately, you can't. This is going to be your final answer.